what comes in the Greenhouse Sense and Control Kit, and how do you use Blockly code to make the components work. The Greenhouse Kit comes with a greenhouse, also known as an eco chamber with rubber stoppers. The kit also includes a control node, which is the device that handles the input and output commands specified in your code. The included greenhouse sensor provides data input from a soil moisture probe and a light, humidity, and temperature sensor. The kit comes with all the cords you need to get everything connected as you see here. The output devices include a programmable grow light, which is powered through an AC wall adapter, plus a fan and submersible water pump, which are powered through the USB plugs on the power output board. Finally, the included Greenhouse Accessory Kit contains tubing, connectors, an additional stopper, drip irrigation heads, and hook and loop strips to keep cords and tubing organized. Your assembled greenhouse will look similar to this. In addition to what comes in the kit, you will need Capstone or SparkView software, a container to use as a water reservoir like this, and either a potted plant or seeds, soil, and a plant pot about this size that fits comfortably inside the greenhouse and allows drainage through the bottom. You can even use a cup with holes in the bottom if you want. Now let's do a little programming with Blockly and SparkView. I've already connected the control node through the sensor data option. The control node has built-in sensors that I won't be using, so I'm going to disable them. These greenhouse sensor measurements are available when the sensor and its components are plugged into a connected control node. I'm only going to look at the temperature measurement, so I'll leave only that measurement checked. I'm going to choose the digits and graph template to quickly build the data display. Select the puzzle piece icon to switch to the Blockly code tool. You'll find the block that controls the grow light in the hardware menu. The light is plugged into port A on the control node. The grow light only has red and blue LEDs whose intensity can be independently set with whole numbers from 0 to 10, 0 being off and 10 being the maximum. If I hit start, the program runs and the light turns on briefly, but then it shuts off right away. Well, that's exactly what my code says to do, to turn on the light, but it does not define how long to keep the light on. So, if I add a sleep block, the light will stay on as long as I say. This drop-down lets me change milliseconds to seconds. The sleep delay is now set to keep the light on for a couple of seconds. Let's test the code. So the light stayed on for a little longer as directed, but what if I want to keep the light on until I hit the stop button? I need an infinite loop set up like this. Repeat, while true. Delete the sleep block. Okay, let's test the code. Now this light should stay on until I hit stop. Okay, stop. Now, if I want the light to turn on and off in a timed cycle, I can duplicate blocks and modify the light intensity. Okay, so let me duplicate the light block. I'm going first to set brightness to 0 on red to make that red light off, and blue, leave it at 5. So only blue light will be on for, let me put a sleep delay to set the time that it's on. So it'll be on for 1 second on blue. And then if I set blue to 0 and red, I'll leave it 5, blue will be off and red will be on for 1 second. And then this will keep repeating. Okay, let's test the code. Great, so now that you've got an idea of how to control outputs, let's work some sensor data input into a program. Let's say that I want to run the light at full power. Okay, so that will be 10 on both red and blue. That's going to generate some heat, so I can use the temperature sensor data to tell the fan to turn on and help keep the greenhouse cool. I'm going to use a logic block to set up a condition where if temperature is greater than a specified temperature, the fan will turn on. Well, let's peek at the current temperature in the live data bar. At the bottom left of the screen, right now it's 26.1, so I'll set the fan to turn on when it's warmer than 26.1 or greater than 26.1. The USB fan is plugged in to the power output module, so I need to grab the power output block from hardware. I need to verify that the fan is plugged into port B on my control node and that I'm on channel 1 on my power out board. And true means on. But if that condition is not met, I want the fan to be off. So I need to add an else statement to this logic block. When the temperature condition is not met, I want the fan off or set to false. Let me switch to the data display. And now let's test the code. So we expect the fan will stay off, it's off right now, until the temperature gets above this value, above 26.1. So while we wait, we can see the temperature stays stable. It's not getting warm yet. As soon as it gets warmer than 26.1, there it is. I can hear the fan. There it goes, right on time. And this fan will turn off as soon as the temperature drops back down to 26.1 or lower. I bet you're already thinking about a bunch of different ways to control the light, temperature, air movement, and other things in the greenhouse. Visit Pasco's experiment library to find classroom activities for the Greenhouse Sensor Control Kit, and visit the kit's webpage for details on how to assemble individual kit components, like the greenhouse sensor or grow light. Thanks for watching! Keep coding and have fun exploring the possibilities.